All right, I think we are live 2 minutes early. Hey everyone, we are just checking the setup, the new changes that we did. Give me 1 second. I think it's good. Good, so we have 1 minute to start. Okay, so Sandeep, it's working. I'm
Okay,
just gonna play on, give you 1 second. Right. Okay. Can you guys see Sandeep's screen? I think yes, you can. All right. Okay, it's time. So now we can officially kickstart Sandeep. Hey everyone, welcome to the VirtualMuleys event 14. Good time, bad time. I hope you all are safe, healthy, wherever you are. So just stay like that. So for today's topic is very interesting, performance tuning with Mule 4. And again, we have Sandeep, who also did our previous meetup. So we have back him here. Welcome, Sandeep. Thanks for joining us today here.
hello everyone.
Hey. So for everyone, just let me know on the right side chat if you guys cannot hear me or have any issues with watching this. Those who are joining us for the first time, there should be a YouTube chat on your right hand side of the screen. We will monitor that all the time. Sandeep will continue with the presentation, and any questions or anything, feel free to drop them on that chat and we will get back to those once his presentation is done. So with that, I think, yes, people are saying they can hear us. So, all right, Sandeep, everything is yours.
Okay, thank you, Manik. Hello everyone. Good morning, good afternoon to whichever part of the world you're joining from. We're going to talk today about performance tuning with Mule 4. So I get a lot of requests from Mule customers that they want to understand what are the best practices around performance tuning. And I thought this might be a good topic for a broader audience so everybody understands how to approach performance testing in Mule. So just a safe harbor statement for everyone to read. So next, just a little bit intro about myself. So I've been working with MuleSoft for the last year. Before that, I have been working with different customers with retail, banking, and insurance customers. I have been working as mostly as a full stack developer. Been working with MuleSoft platform for about 2 years now. I was working with a MuleSoft customer before I joined MuleSoft, and they use MuleSoft heavily for their external system integrations. So I completed a couple of certifications last year, the architecture certifications and the developer. So yeah, that really helped me gain knowledge on this platform as well. So the agenda today, what we're going to start with is I want to help you guys understand a little bit about the Mule 4 execution engine, because I think that's the core value of the product, like how the core engine works and what are the parameters you can think about tuning. So we'll have a little bit of understanding about Mule 4 execution engine. Next is what is performance profiling? What are the steps when you do your performance testing for your Mule application? And then we're gonna talk about few tools that you can leverage for your performance testing. Then I will show you a quick test on JMeter and if time permits on a SoapUI tool as well. And lastly, we're gonna end with a Q&A. Let's get started with the execution engine. So just to give you an idea of the new Mule 4 execution engine. So we did a dramatic change of what our execution engine was for Mule 3. We have a new mechanism which follows the non-blocking principles. It's basically based on the Java reactive programming concepts. So everything is a non-blocking call in Mule 4. So earlier in Mule 3, we had a lot of issues when we were like switching the thread context. With new Mule 4, there is the thread do not wait for the IO blocking calls. They just execute seamlessly, and the execution engine is smart enough to understand which thread needs to be allocated for which process. Next, then we have divided the event processors into three different categories. So we have divided the event processor in CPU intensive, then CPU light, and IO intensive operations. So those are the three simple categories that each thread, each event gets executed in. And finally, the new default class loading mechanism. So earlier, everything in the Mule 3 execution engine, the connector libraries as well as the execution engine was tied together. With the new class loading, class isolation mechanism, we are able to decouple the execution engine and the connector libraries. So let's dig in deep into that. So if you look at this class loading module, right? Now here you can see that your code and your execution engine has separated. So earlier, if you wanted to upgrade a HTTP library, so you needed to upgrade the entire runtime. But with the new Mule 4 execution engine, you can simply upgrade the connector version and don't worry about your application failing. So so your application runs separately from the internal Mule code. And even this even allows you to do things such as have your own Spring version because it's completely decoupled. And then again, we have like new well-defined Mule APIs to extend your Mule application as well. And so even if now, suppose there is a new version of your Salesforce connector, so it is easier to upgrade the connector versions and add them as a dependency in your Mule application compared to the Mule 3 execution engine. So that's like the class loading in Mule 4. Now comes the new self-tuning runtime. So if you see, all the threads in the Mule are basically categorized by the scheduler engine, and it will categorize if the event is a CPU light event, if it's a CPU intensive heavy event, or it's a IO event. So all these threads are basically, if you have one core machine, then we have formulas by which we calculate the number of CPU light threads, CPU heavy threads, and IO threads. And if you want to take a look at the formulas, the we have the code in our open source GitHub system. You can go there and understand how many threads are allocated for each core of your runtime. And if you are on-prem, you can easily go in your conf/scheduler pools conf folder, and then there you will see how many threads are allocated for your runtime. So what are these IO intensive, CPU intensive, and CPU light threads? So IO intensives are basically when you have something like a DB operations, and we have some blocking IO operations like transaction scopes and all that. So those are categorized like IO intensive operations. Next is the CPU intensive. So CPU intensive, like data weave transformations. Then if you have Groovy scripts, all those are categorized as CPU intensive operations. And then we have CPU light threads. So switching between one event to another, the message passing, that's categorized as a CPU light event. Then we have filtering. Then we have routing from one flow to another. That's termed as a CPU write event. And then again, non-blocking IO. So these are basically the more, this is how Mule 4 is focused on different threading profiles. And again, next is, I just wanted to give you an idea of the formulas, how the CPU light threads and intense and blocking IO is calculated. So if you have one core machine, then the number of CPU light threads that are is 2. So 2 into 1 is 2, right? So similarly, we have CPU intensive threads. The same formula goes for CPU intensive, and then we have blocking IO. So blocking IO pool is calculated using this formula. So depending on the codes you have, you'll get that many blocking IO threads. So now that we understand how the threads are calculated, the auto tuning part of Mule 4 execution engine. Now you wanna do your performance testing in Mule 4. So firstly, we need to understand what a performance testing means to you. So performance testing can very well help you analyze the performance of your system. So it can give you an idea about which are the poorly performing pieces of your code. Then it can help you collect statistics. So if you are struggling with the performance of your API, it can help you gather the statistics like your CPU usage, your memory, your thread, then your responsiveness for that application. So those are the important statistics here that you need to know. The next is the optimization of the code. Then you can also optimize the code once you know what the performance is by going granular to the process level, thread level, or SQL level. And next comes the sizing. So doing performance profiling or testing gives you an idea of what the application size should be. So this is a very critical step when you're trying to go to production. You need to size your applications to handle the right data loads for production loads. So performance testing gives you those capabilities. And finally, like fine tuning. If you're not satisfied with your performance and you need to be in compliance with your NFRs, then you can keep on fine tuning your applications by iterative performance testing. So I'll give you, right, why is it so critical to do performance profiling or performance testing of your applications? Take two scenarios, like every day, right? We'll take a scenario of retail industries. So in retail industries, there are multiple occasions, right? When there is a promotional deals going on Black Friday, on Christmas, or on Cyber Monday, suddenly you can see a spike of requests that are coming to your system. So it's very critical that you manage or scale your systems according to the load that you are expecting in those days or like in those holiday periods. So retail industry needs to make sure that their applications are sized correctly. Next is the insurance industry. Now I'll give you an example. I had been working with the insurance industry before this, and we had a scenario where if some natural disaster happens and simultaneously thousands of users are trying to upload their claims data, right? So claims data can be photos, it can be videos of the property, and all those data need to be handled with your backend systems, and which is all that data is going through Mule, right? So you need to make sure that all that data is easily being uploaded and there is no problems or your systems are not breaking at that point of time. So this is why we should do performance testing, do performance profiling to make sure that you're optimizing your code. Then the steps of performance testing. So basically, what I recommend the customers is performance testing is a must do. If before your go live, you need to know that your systems are capable enough to handle all the production load. So we categorize it into different 7 steps. So first of all, you need to identify the testing environment. When you say testing environment, it may be on-prem or your CloudHub. Then we need to identify the performance metrics, the throughput, latency, and all those metrics need to be identified that you need to capture. Then finally design your performance test depending on what the requirements are. Then actual test environment where you're going to do your testing. Then finally you implement your design steps and then run the test and do analysis on the report. So we're going to dig a little deeper into all of the steps and understand what is the process involved in each of this. So identifying the testing environment. So whenever you're doing your testing, right, there will be a client who is going to send request to your Mule app, and then Mule app is either going to interact with the backend system or do some process and send back the response. So it is very important for you to understand where this Mule app is residing. So there is three different deployment options, right? We have the deployment model where you can deploy your application in CloudHub, or it can be in Runtime Fabric, which is another on-prem customer-hosted deployment model. And then we have on-premises, which is like your Mule execution instance engines are installed in customers' VM or data centers. So first, I'll just give you a brief introduction about CloudHub Runtime and what it is, so everybody understands what we are talking. If somebody doesn't have experience with CloudHub, this will help them. So CloudHub is basically is an environment which is deployed on Amazon AWS. So MuleSoft has an account in Amazon AWS where we deploy all our cloud applications which are deployed in CloudHub. And one thing to note about CloudHub is every application will have its own separate Mule runtime. So we deploy the applications in what we call as workers, which are similar to servers on on-prem. And on each server or worker, they have one single application. So scaling happens in multiple workers. So if you want to have multiple replicas of that particular application, we deploy it in different workers. And then we have different features for CloudHub, such as failover capabilities, and you can also deploy your applications using Anypoint Runtime Manager, which is your web portal. Next is the CloudHub infrastructure. So we have two capabilities for customer. So in CloudHub, if you're deploying your application, it is again shared with all the customers, this particular environment on the left-hand side. And each Mule application will again have its own server and own execution engine. So that's one thing to note. And another option we give our customer is to have their own dedicated private IPs, like a network space within AWS, and whichever applications will be deployed in that particular VPC, that will be only dedicated for that particular customer. Again, same thing, same concepts. Each application will have its own execution engine. And again, a few things to note about CloudHub, right? I told this in my last meetup also. So point 1 and point 2 vCores have bursting capabilities. So if you're doing performance testing for those kind of applications, you have to understand that it will only perform better for a short period of time. So that's why it's very important whenever you do performance testing on CloudHub applications, warm up your servers, like send few requests before you do your actual performance testing. And again, like load balancing is something that we provide out of the box with our shared load balancers. Next comes the Runtime Fabric. So Runtime Fabric is basically a container service that automates the deployment and orchestration of your Mule application. So we provide you images of our runtime, and what you do is just deploy it on your Kubernetes cluster. And the infrastructure can be anything from AWS, Azure to your virtual VMs. So we have different options, but all the infrastructure resides on your customer's side. So customer will host the infrastructure. Again, the concepts in Runtime Fabric are similar. We provide application isolation. So each application will be isolated and will have its dedicated memory and CPU. Scaling is similar to CloudHub. Will have option for you to have multiple replicas. So if you have more than one, you want to replicate the application in different zones, then you will have that capability. And again, we have the capabilities to manage those applications using Runtime Manager. So this is a logical architecture, I would say, for the Runtime Fabric. So on the top, if you see, we have the 3 controller nodes, that's what we call them. And we have the Runtime Fabric services that help you manage the worker node. So at the bottom, we have 3 worker nodes where every application is deployed. And then, okay, this is in the back, we are using Docker and Kubernetes principles. So if you're doing replica, one app will be deployed in one worker node, and then another app will be deployed in another worker node. So it's very important to understand, right, all these concepts, because then there comes a time about the incoming request, the load balances. So all these concepts will help you to understand how the performance testing will work in your environment. Again, in Runtime Fabric, we also have come up with a new bursting capability. So if you know that this application might have peak loads for like once a month or twice a month, you can try to allocate resources from that worker node. So whenever there is a burst in that particular application, it will try to use the remaining CPU from that particular worker node. Next comes the on-prem. So on-prem, again, we talked about it last time. Again, I want to just take a minute to revise. So on-prem, again, all the applications will share the single runtime. So if your application, when you deploy an application on the runtime, it is shared by other applications too. So on-prem may have like large, so customer has the flexibility to allocate memory to the on-prem resources, but CPU still remains the same. So this is an example of on-prem infrastructure. So on the left-hand side, if you see, it's very important for you whenever you do your performance testing to make sure that you're doing your performance testing in an isolated environment. So you don't have other applications which are computing for resources when you're deployed on-prem. So make sure that there is just one app and one app deployed on that on-prem system, or like try to isolate it somehow so that the performance testing results yield you the true results and not like cluttered with other applications. So on the right hand side, if you see, this is like a typical production deployment. There's multiple apps deployed in a single runtime. So once you identify the testing environment, next is identifying what performance metrics matter to you. So this is something that you need to work with your business. So when I was working with the customer, we had a step where we used to sit with the business and we used to come up with the metrics that are acceptable for that particular use case. So we used to have like, what is the high TPS that is expected, what is the average, and what is the normal TPS that you should that is acceptable. So usually you would come up with the throughput numbers, what is the responsiveness of that particular API, and then the startup time, right? How much startup time is required. Then memory footprint, how much memory that particular app should occupy if it's on-prem or it is on cloud. So on the right hand side, I just want to take a second for this. So you can always have you cannot always have all 3 parameters like latency, memory, and overhead. So if you choose that you want memory and latency to be reduced, then of course you have to add more CPU resources, right, for that particular use case. So it is always like you can only choose 2, and you have to like sacrifice on the third one. So you will come into scenarios where you will see that you can only achieve 2 of those parameters. Again, if error rates, like what is the acceptable error rate? So if you're having a spike testing and there's like certain percentage of errors, are those errors acceptable? Like if your HTTP cannot handle that many requests. So what is the acceptable number of error rates for that particular application? And next is the application and server CPU. So understanding like what are the metrics available and what are the criteria for that application and server CPU. That is that is something that you need to work with the business and have better monitoring established. And again, next comes the step where you actually plan and design your performance test. There's different types of performance testing, right? Load testing, where you are uh, increasing the workload and checking how much load your systems can take. Next is the stress testing. Stress testing is usually used when you are trying to break your system. So you understand, okay, this is the breaking point of my system. So that could be stress testing. Next is the spike testing. So suddenly, if you see a high volume of requests coming in, you would want to test that scenario as well. So spike testing is something that our retail customers most of the times use. Then we have endurance testing, which is like for how long you can keep the same workload for extended amount of time, like high workload. So that's endurance testing. And scalability testing is how if there is multiple users logging and using the system, how does that perform in those cases? So that's scalability testing. Next is plan and design your performance test, right? You need to know who is calling the Mule application. Is it like a web portal? Is it a mobile device? And how many devices are going to access? So all those numbers should be with you handy before you start doing your actual performance test. So it all depends on if you have any other APIs that are calling your MuleSoft APIs. So all these parameters or like considerations need to be done when you're designing your performance test. And again, like you should know what the expectations are. Like you should set those NFRs before hand when you're doing your performance test. And now, just giving you an example, right? So some of the performance test cases can be verify the response is not more than 4 seconds when there is more than 1,000 users logged in. So that's a valid request, right? The business can say that I don't want user to wait on the screen to load for more than 4 seconds. So that's a good performance test to try out. Then again, if we are having some issues, if the user is having low network connectivity, so how much time is it going to take for the most valuable data to load, right? So that's something that you can test. But again, this will be like a holistic approach to the business users. So these are some of the examples that you can have in your performance test. And this is, I think, one of the most important steps, like configuring your actual test environment. So you need to know that the production environment is exact, that the performance testing environment is exact replica of production environment. Because this is a very common mistake for our on-prem customers, where they allocate less resources, less CPU, and less memory in their performance testing environment compared to production. So they don't actually get then realistic view of what their production results are going to look like. So we always recommend to have a replica of their production environment for test. Next is isolating the test environment. So another good example is make sure that there is no other applications. In case of on-prem deployments, make sure that there is no other applications that are running whenever you're doing your performance test, because those other applications are going to compete for the resources and you'll not get the right performance testing results. Next comes the network isolation. So make sure that again, like if you are in a internal network, make sure that there is no testing happening for other web applications or any other things that will slow down the network. And data generators, try to be as realistic, have the data as close to the production data, so you have better results when you're doing performance testing. And proxy servers are always known to have cause performance issues. So if possible, directly hit your Mule endpoints to get an understanding of how much time a Mule API is taking. Next is warming up servers. So the last time we talked about, right, in CloudHub, we need either a for if you have a point 1 or point 2 worker, it's very important that you warm up those servers and before you do your performance testing to get the accurate results, because they give you good performance for a short burst of periods, and after that you may see a degradation in performance. So it's very important to warm up your servers. Lastly, again, JVM, having the right JVM, the same JVM in production and non-production environment is important. Some customers have Oracle in production, non-production has adopt JDK. So it's very important to replicate that. Next is implementing your test design. Once you have your four tests planned and done, then there is a time where you need to actually implement your test design. So usually you would do like a section with prerequisites, the test procedures, which are the scripts, next the guidelines, timelines, and the tools necessary to do the performance test, the criteria, the test data, and the test environment. So on the right hand side, if you see, once you tune and test the infra tools, you have like a baseline testing done. This is where you get the uh, baseline numbers of your Mule application, and after that you can do, depending on your NFRs, you can tune and test your infrastructure. So that's an iterative process. So performance testing is not something that you can do once and it's done. Till you get your till you get the results you want, you need to keep on tuning and testing your Mule flows. So next comes the running the test. So again, like we talked about, we have to keep on running the test in iterative fashion, monitor them, and again profile, and then see if you can tune another parameter and which will yield you better results. Next comes monitoring. Now observing the behavior. So we have different monitoring metrics. So you have the response time, you have uh, concurrent users that you need to keep a track of, then TPS, what is the TPS for an API. Next is the success to fail ratio. How many transactions were successful and failed requests. Then error rate, what is the acceptable error rate, and is there a proper exception handling and all those things working whenever there is an error. And the infrastructure metrics, something like CPU utilization, which we usually recommend should not go beyond 75%. Memory, again, same like 60 to 80% of memory utilization. Disk utilization should not be more. Make sure that the temporary folder in your disk is getting deleted and all the things are performing as expected. Network utilization is again something, if you have the APIs deployed in your data center, make sure that the network utilization is not going beyond certain limit. So when you have, when you start testing your Mule application, so one thing, if you have ever used JMeter or any other performance testing tool, you need to think about the number of threads you want to start with. We usually recommend like starting with a lower limit, and then you can have like a ramp up of those. Next is actually running that JMeter test. If successful, just increment the threads or the payload size, and until you break it, don't stop, and you'll understand what is the baseline of your system. What is the stress testing? You'll complete your stress testing as well. And next is graphically represent those data. So graphically, you can either use the anypoint monitoring that is available out of the box, or you can use different performance tools such as JMeter to export that data. Again, this is again it's a journey, right? Performance tuning, again, I've not seen it like done in like within a couple of hours. Every customer finds the right balance of depending on what kind of applications they have deployed and what kind of operations are being done in that particular Mule application. It's usually we recommend to you to tune one parameter at a time, so you don't get confused of what the parameter affected in what way. So don't change a lot of things and do the performance test. Change one parameter, see if it is affecting the performance, and then move on to next parameter. So this avoids confusion and gives you more accurate results. And again, one size does not fit all. So if one application is sized for two workers, it doesn't mean that all the applications will require two workers. You have to do performance testing for each individual API because it will depend on what the connectors that you're using in that app and all the other factors. Again, you need to find the inflection point, the point where your application starts to degrade. So keep in mind and keep an eye on what the inflection point is, so you know what the limits are, and you can see if that's satisfying the NFRs as well. So one thing I've always talked to customers, like some customers directly deploy their application to 1 week. So what I usually recommend is like start from like 6 workers with 0.1 week or see the performance on that. For like they can start with 5 workers on 0.1 week, right? Start with like the smallest fractional core and then go on incrementing. So you might even see better performance in cases where there might be only 0.2 week core workers deployed in 2 different regions compared to 2 week core workers. So it really varies, and that's what our recommendation is as well. Like try to scale out the workers before scaling up. And what are the tuning options, right? If you are seeing that your application is not performing well enough, so Mule has some design patterns. For example, scatter gather flow, which can improve the through the processing time of your APIs. We have a caching mechanism that is available to make sure that the retrieval of the records is faster. Then we have batch processing for streaming your data. Then we have a VM queue, which is like a in-memory queue that you can leverage to you know process the records in order or not. Then again, we have flow references, policies, synchronous, asynchronous flows that you can leverage. And then we have transformation. Data weave is usually faster compared to Java or Groovy. That's what we have found. Next is scheduling. Like if you have schedulers, or you can schedule jobs whenever there is downtime in your in your traffic. So you can schedule some jobs at night when you don't have a lot of traffic for that application. And then again, logging. So logging in as another big culprit, right? I've seen a lot of customers logging entire payloads in the Mule application. So that slows down the application, increases the use of memory, and it also takes resources. So keep your logging as minimum as possible. Don't log entire payloads. Don't convert it to string and then uh, display it in your loggers. It just takes up a lot of memory. Now, some applications do have API policies, and I get a lot of questions from customers where they're like, "How much performance is going to get affected if I add this certain policy?" So on the right-hand side, if you can see, we have the numbers on how much milliseconds that will be added if you add a certain policy. If you're adding a certain suppose rate limiting, so we see usually increase of 24 milliseconds of API response time if you have a rate limiting policy. Similarly, you can see in this chart, we have different numbers for different policies. And next comes the data transformation performance. So every time you're doing your data weave transformation, it does take resources, right? So if you're doing a transformation, which is XML to XML, so on the left-hand side, you can see that it's in the millisecond. So the XML to XML transformation may take up to 1800 milliseconds. JSON is comparatively lower. So usually we ask the customers to keep all the data in an object payload as an object. We have seen that that's the fastest performing data type. Again, the performance tuning process, you to profile your applications, tune and patch, and keep on testing the same thing. So just to highlight this image, uh, we usually use the testing tools such as SoapUI, LoadRunner, or JMeter. In Monitor, so we have visual VM. So on-prem customers have the capability to activate visual VM. Then we have top command, so we can see the top consuming threads. And then we have heap dump. So we have a support collector process which can help you get the heap dumps, and using memory analyzer tools, you can check what's wrong with your memory or which component in your application is taking a lot of time to process. And again, tuning, right? Misconfiguration. So I've seen a lot of customers who have like over allocated their heap memory just because they couldn't tune the application design. So it's very important for you to first think about design time tuning instead of infrastructure. So if you have bad design, then it's just gonna get you more in trouble. So before you do your infrastructure tuning, take a look at what kind of design patterns, what kind of flow variables you have used, and what you're storing in them. Again, then sometimes the issue might even be in the Mule runtime, right? There must be some performance, there's some bug in the runtime that you may need to work with the support and get a patch for that. So try to do initial performance tests. If you're not able to figure out, open a ticket and check if that's something related to the runtime as well. So the tools that we have available for performance testing is, these are all open source, right? This is the LoadRunner, Apache, JMeter, and SoapUI. So I have done most of my testing in JMeter, and SoapUI has some capabilities, but I don't usually use that. And some of the cloud-based performance testing providers are Flood.io. That's something that I've tried before. Then we have AWS Device Farm, Load Impact, Sauce Labs. So all these tools, you can decide which one is easier for you to use and do those testings. Again, monitoring tools that we discussed, we have the anypoint monitoring. Suppose you have a Titanium subscription, you have a lot of graphs and a lot of insights of all the applications that are deployed. Next, we have in the runtime manager, you can also see how the server is performing, how the CPU and the memory is being allocated to the particular worker. Again, JVM monitoring tools, Visual VM, GC, or there's different tools you can use. So some of the typical issues, right? What kind of issues you see? Sometimes you see that the CPU is getting spiked beyond certain limit. Like if your CPU is staying above 90%. So what I've seen in those instances, you can either, if you have an on-premise systems, so we have something like a T-top utility shell script. So you can find basically whenever you're seeing this spike, go to your runtime, log into your server and run this top CPU command. You'll at least know that which thread is taking longer time. Is it something is stuck and it's just not releasing that thread? So you'll easily find out those top CPU consuming threads. And if it's a CloudHub, right, application, customers don't have access to the server. So customers basically have to work with the support and get that kind of data. So we usually recommend open a support ticket and find out if there is some issue with the threading in your application. And again, CPU burst, they expire for fractional weak hours of CloudHub, so it will eventually perform less. Now memory. So if you have bad jobs which you did not test with the realistic payload, and you're seeing a lot of memory being occupied, Then recently I just talked to a customer where they were having Java heap memory problem where one of their APIs was consuming up to like 90% of heap. But when we actually did the heap analysis and found that they had logging all over the Mule API, and when they optimized it, they saw a reduction more than like 50% of heap memory being used. So it's very important that you collect the heap dumps and use memory analyzer tools. For example, I know one that is Flood IO, and another tool that we have is Eclipse Memory Analyzer, something that helps you understand which is the if there is any memory leak suspect or which is the component that's taking up all the memory. Again, batch expiration date, if there is something that you need to explicitly expire, if something is wrong, you can set the expiration age for the batch process. And another thing is temp files. So every Mule runtime has a temp folder. So inside that temp folder, usually you have like data weave, temp files, or some other connectors use this file, use this folder to create some temporary files. So sometimes those do not get deleted, and you see that out of disk space error. So you can go in your, if you're on-prem, you can go in your temp folder and check if there is something that is taking up all this space. Network again, network latency is something that is a very typical issue that I have seen. So I was working with one of the utility companies, and they were having issues with their performance. So when we went in and tested the APIs from internet, we saw a very lower TPS compared to when we tested it within the data center. So we had another server within that data center and tested that API, and we saw much better performance. So it was because of the network latency. So it's very important that you take that factor into consideration. Again, token expiration, like if something happens, like the token expires and you don't have proper mechanism to refresh that token, usually you will see that the error is these errors when you're doing performance testing. Okay, so this was the theory part. I'll just show you one demo, quick demo with JMeter, and how you can find out what is the TPS and all that. So this is the open source JMeter tool, right?
Just quick time check 12:45.
Okay, I think we're good with time. So this is a JMeter tool. So what we'll do is create a new test plan. So when you go in a JMeter tool, this is the layout you will see usually. And what I want to do is now create a new thread group. So thread group is if you want to replicate having 10 different users or 50, you would create a thread group. So let's take a thread group of 50 users. Then ramp up period will be 1. I don't want to forever loop count. I'll use a scheduler, and I'll run this test for 5 minutes. Startup delay, we'll keep it as 1 second. Next is you wanna add the listener. So I wanna add a HTTP request. Okay. So I have a API that is deployed on CloudHub. So I have this API that is deployed on CloudHub on 1 vCore, and we're gonna do a performance test on this API. So go back here, my URL is HTTPS, then my server is the CloudHub server. Then the port number is 88443, and the path is Okay, and then we're gonna add. So we want some metrics, right? We wanna see. So we wanna see the result tree. Then we wanna see the sorry. We wanna see the thread allocation. 1 second. Yeah, so we wanna see this, and then we wanna see summary report. So what we'll do is now we have this HTTP request. We'll just simply run this API and see what the results. So in the results tree, you can see that the APIs are some APIs are getting error, while some are getting successfully sent. Then in the summary report, you can see that my TPS is 225. So I'm getting 225 TPS for this particular API. The error percentage is 1%. This is probably because we are using a shared load balancer URL here. So shared load balancer has a certain TPS limit. Beyond that, you'll get like a flow back pressure error or a 503 error. So this is how you would usually do your JMeter test, and it will give you a basic idea. So one th one thing to know here, right? Sorry about this. One thing to notice here is that even the machine that you are invoking the JMeter from, even that affects the number of thread it can spawn. Since I have a MacBook, it can spawn more threads, but if you're doing like you're using a VM AWS workspace and it cannot spawn a lot of threads, you can see that it has lower performance. So the machine where you have the JMeter installed also matters when you're doing performance testing. So this is our JMeter test, and this is one plugin that I've used. So it gives me the graphical view of if there are 50 threads, I'm getting 246 average TPS. So this is a JMeter test. Let's see a SoapUI one. So a SoapUI, it's similar to this. This is a SoapUI tool. So if you create a new REST API, just put in the URL. This is HTTPS. And so this is a health check API. Now you want to create a test suite. Sorry. So generate a test suite. So once you generate the test suite, suite will get created. And that this is something different. Let me show you the one I created. I'm creating the wrong one. So this is usually how it will show up. So you will create a REST API endpoint. Inside that, you will have a way to create a test suite. And within test suite, you can create a load test. So in this load test, so I'm using 50 threads. And then again, test delay is 1000 and the time that I'm using is 60 seconds. So if I run this test case, so you can see I get the TPS count here, and I don't really trust the SoapUI numbers, but yeah, I mean, this tool is something that you can use to get some performance testing done. But yeah, the SoapUI tool has the capability. Yeah, I mean, this is about the demo. I have some good links for you to refer to in this presentation, which I'll upload after this meeting. Manika, I think we can take the questions now. Hey, Manik, can you hear me? Hey, Manik, can you hear me? Hey guys, can you hear me? I don't know. I think Manik's Zoom has frozen. I can see the questions. I can start answering those. Can someone reply in the chat there if you guys can hear me? Hey, so for on-prem JVM, right? So I'll take the first question from Heather. Do we need to tune something for on-prem JVM or at OS level? So usually, whenever we provide the runtime, it's tuned to the optimum settings. But customers decide usually to have more heap memory for their on-prem systems. So I've seen customers allocate more memory, go into the wrapper configuration and change those heap parameters. Another change I've seen customers doing is related to some, in rare cases, they change the garbage collection algorithm. So those are a couple of configurations that customers usually change. Next is, can we deploy service mesh in our own Kubernetes, or is it only on any of cloud providers, GCP, Azure? So right now, service mesh, I mean, it's not part of this topic, but I'll still take that question. Service mesh right now only supports, like you mentioned, right, Heather, it is only supported on GCP, AWS, and Azure. It can, so the way it works is you will basically install the MuleSoft adapter in your Kubernetes cluster, and that adapter is registered on the API manager. So for now, just those three providers. Next is how many temp files in CloudHub does that get cleaned automatically? So yes, the CloudHub will inherently clean up those temp files. DataWeave usually creates a temp file when it's doing its transformations, and it is expected from data like within the runtime to clean up the temp folder after it's done. Sometimes you have different connectors, which I don't recall right now, but they also create some temp files. So in those cases, we have seen that customers need to explicitly go and clear it out or work with support. Next is, it will be, okay, somebody answered it. So JMeter, do we have option to change the payload a couple of elements? So I believe so. So I was using a GET request. So I'm pretty sure there must be option for you to have different payloads. Insights on how Mule does garbage collection. So MuleSoft, again, like I said, right, when you download the runtime, you get like default garbage collection algorithms, and you have different settings. So those are the optimal, but internally, it just works like any other Java server. It will do its garbage collection once it reaches the peak of the heap memory. Like you have a parameter where you assign that if I have 10 GB of heap memory, garbage collection should be done at 8 GB. So you'll see like a major GC happening at every time the heap memory reaches 8 GB. And then there is also minor GCs that run depending on the garbage collection algorithm. So we usually don't ask the customers to tune that parameter, but because the one we have given you as default works the best with Mule execution engine. JMeter, I mean, I'm pretty sure, guys, there must be some online articles on how you can pass dynamic values. You can just do a Google search. Lokesh has a question where 0.1 vCore by default has 500 memory RAM and 8 GB ROM. Yes, so yeah, we have those numbers on our CloudHub, on our docs channel. You can see for 0.1 vCore, 0.2 vCore. Any other questions, guys? Manik, can you hear me? I think we're done with the questions. Hey, Mahesh, if you're having issues with the heap size, make sure that you take a heap dump and at least run it through the memory analyzer so you know what is taking up the heap. If there is any scheduler jobs that are continuously running, maybe that's something that you need to check. And if it's not going beyond some 8 GB, I don't suspect there is a memory leak. You just need to check what's running on that runtime. Okay, great. Thanks, guys. I know this is like crunched up session. Usually we take a couple of hours to do this performance profiling session, but I tried to keep it on the topic and so that everybody could relate to it. Thank you, and talk to you later. Bye.
All right. Thanks, everyone. I tried joining back from phone, so maybe it's working. I don't know. Okay. Have a good night, good evening. Take care. Bye-bye. Thanks, Sandeep.